Okay, next lesson is called theoretical and experimental probability. Now, when you're taking notes on this, you don't necessarily have to write what I already have written to set up for your notes. I do want answers, though, and definitions. So that's what I'm going to talk about first. The difference between experimental and theoretical probability. So, experimental probability, underline it, it's found using frequencies obtained in an experiment or a game. Okay? It's found using frequencies obtained in an experiment or a game. So, and again, it's like what you actually predict what your outcome is going to be, when a theory is already what's expecting. So let's write it. It's found using frequencies. So you're going to see some statistics today. Frequencies, data, obtained, which means received, in an experiment or game. Theoretical probability is the expected probability of an event actually occurring. Okay, so very simple example. You're a captain, again, walking out into the middle of the field. Your probability of landing on heads that you call for is a 50% chance. Well, the experiment is proving that. So the experiment of the theory, well, my theory is that I'm going to get a 50% chance of getting it, and it does land on heads. You had a 50% chance after the experiment or the game occurred. So let's practice this. We need to make sure we have a clear understanding of the difference, and I think a couple of these examples will help with that. So the first example I have here is we're voting, okay? And in a poll, 225 people were asked for whom they planned to vote for in the race for mayor. What is the experimental probability of Jones getting a vote from a person selected at random? So Jones, out of the number of people voting, 75 voted for Jones, 67 voted for Davis, 83 voted for Adams. Well, out of 225, that is your key note you need to take away from this problem, is knowing that fractions are part of a whole amount. So 225 is our whole amount. So out of 225 people, and if the experiment is 75 voted for Jones, you would then simplify that to 1/3 of the population voted for Jones. Okay, so that's the experiment. Now, suppose, if we took this a step further, suppose 5,700 people vote in the election, not 225, 5,700 people vote in the election, though. How many can be expected to vote for Jones then? You multiply it. 1/3 is the amount of what was selected at random. So you would multiply 1/3 times that 5,700 to get 1,900 people will vote for Jones. Remember, you got to multiply it, though, in order to receive the exact amount. So if 1/3 of these people in the election voted for them, because 75 is 1/3 of 225, you take 1/3 and you multiply it by how many people actually voted in the election in all. Okay, this was selected at random as a survey to see who might win. Well, in the actual election, 1,900 people voted for Jones. So that's the probability of an experiment and the likelihood of it actually occurring from the theory, 75 out of 225. I like this one a lot. Number 2, use the graph of a survey of 150 students asked whether they prefer cats or dogs. So if I were to ask you all if you prefer cats or dogs, we'd collect some data. And that data would, or the frequencies I could be saying, is discovering what the experimental probability of a student in class preferring dogs. Well, looks like 18 are preferring cats, 132 are preferring dogs. So if you were to see what the probability is, that would be out of how many? 22 out of 25 would be it reduced in simplified terms. So if you did 18 out of 30, or 132, I should be saying, and you add it to get your total, so 132 plus 18 total students in all is 150. Well, 132 over 150 reduced is 22 out of 25 students would prefer dogs. If you want to get a percent, because sometimes big ideas or whatever we're using is going to ask for you to find the percent of that. You put 22 inside the den, or you can cross multiply. All percents are out of 100. Is over of equals your percent out of 100, and you can cross multiply. Okay. Let's see. It would be 88%. B, suppose 100 students were surveyed though, not 150. They're saying 100 students were surveyed. How many can be expected to prefer dogs? Well, you take that percent, 22 out of 25, and how many would prefer dogs? If you take 22 out of 25, you make it equal, it would be, again, that 88%, because once you divide this, you get 88 over 100. C, suppose 300 students were surveyed. How many can be expected to prefer cats? Well, same up here. If we had 132 over 150 reduced to 22 out of 25, for cats, it would be 18 out of 150. And once you divide it, you get about 36%, or 36 people, kids, would prefer cats over dogs. You just got to do the math and find your percentages. Remember to find your part of your whole amount that they're being asked, whether it's like 150 for the start or 100. Suppose 300, though, you divide it. Okay. One more I want to do with you, number 3. The graph shows the results of an experiment in which a number cube was rolled 100 times. Find the experiment probability of rolling a 3. So if we have a dice, you have a 1 out of 6 chances for rolling a 3. Well, after doing the experiment, this is how many students or number of rolls. So out of 15 rolls, or out of 14 rolls, there was a 1. Okay? Out of 2 rolls, I'm sorry, out of 13 rolls, they showed a 2. Out of 16 rolls, it was a 3. Out of 19 rolls, it was a 4. Okay, and so on. What is the probability, though, this problem's asking is if you were to roll a 3? So the number, I'm going to write it like this. The number of times 3 is occurring in your experiment is being divided by the total number of possible outcomes. So you would take that 3 one right here, and it looks like it was 16 times, okay, out of 100, or reduced 4 out of 25. Because remember, that's your total. So the experimental probability of rolling a 3 is 4 out of 25 chances, which is close to its theoretical probability, 1 out of 6 chances it's going to fall on a 3, because there's 6 sides on a dice. I'll say that again. The experimental probability of rolling a 3 is 4 out of 25 chances, which is pretty close to its theoretical probability of a 1 out of 6 chance we're going to land on a 3. Okay? So making sure you understand the difference between a theory and an experiment. And again, I like the dice example. Making sure that if you are predicting something, that's your theory. The experiment after you do it is actually your answer. Okay, you actually get rounded a 17% chance of rolling a number of your choice when you're playing a dice.